I'm A.J. Schwichtenberg in the College of Health and Human Sciences at Purdue University. So we know a lot about Alzheimer's. Ultimately, we know that there is an early onset type that influences people as young as 30, but more likely in their 40s, 50s, and young 60s. And then we have a later onset type that tends to have the first signs happening at 65 and on up. It is the most common type of dementia, affecting more than 6 million Americans. In order to understand the role that cerebral spinal fluid can play in Alzheimer's, I want to explain two things. One is that we know that the buildup of amyloid beta in the brain is a part of the pathophysiology of Alzheimer's. The other thing is we know that CSF, or the movement of CSF, is key in the removal of amyloid beta and other types of metabolic waste. Throughout the course of the day, we go along having thoughts, creating all sorts of patterns of excitation in the brain. That excitation creates metabolic waste, and ultimately that has to be cleared out. That's one of the key roles that sleep plays. We know that during sleep, our body creates CSF, ultimately allowing for the clearance of metabolic waste that we've created during the day. And from animal studies, we also know it can help with the clearance of amyloid beta, which is what brings us to our current study. Ultimately, we know that CSF turns over during sleep. But what we don't know as much about is during different stages of sleep, how that impacts the movement of CSF and ultimately the clearance of metabolic waste and beta amyloid. We also know that the movement of CSF is linked to heart rate and is linked to respiration. So for this reason, we are asking people to come into the MRI facility at Purdue, fall asleep in the MRI machine so we can look at their breath, their heart rate, and their sleep stages in their brain and how that relates to CSF movement. We get really excited when we think about the long-term implications of this line of work, or how it is that it could improve the lives of individuals with Alzheimer's or their families. We don't think this is going to be a cure for Alzheimer's, but we do think it has the potential to impact the developmental progression of the disorder. Ultimately, anything that we can do to help improve the clearance of amyloid beta and slow the progression is a win in our book.